Section 4.7, rounding decimals. Rounding decimals is no different from rounding integers. These are the exact same rules as before. You determine the place value that is being rounded to, you look at the digit to the right, and if the digit is 5 or larger, you round up, otherwise you round down. I want to remind you again what the names of the decimal places are. So this is the hundreds place, this is the tens place, this is the ones place, this is the tenths place, this is the hundredths place, and this is the thousandths place. In some problems, you'll be asked to round to the nearest integer. Rounding to the nearest integer is the same as rounding to the nearest one. Example, round 21.843 to the nearest integer. 21.843. Rounding to the nearest integer is like rounding to the nearest ones place. So we look at the digit to the right, it's an 8, we round up. So this is approximately equal to 22. Example, round 21.843 to the nearest tenth. 21.843. This is the tenth place, we look to the right. That's a 4, it's less than 5, so we round down. It's approximately equal to 21.8. Example, round 21.843 to the nearest hundredth. 21.843. This is the hundredth place. We look to the right. It's a 3, that's less than 5. Approximately equal to 21.84. Section 4.8, calculators and decimals. Many calculations with decimals are done on a calculator. However, using a calculator will introduce new types of problems that you may not have run into before by doing calculations by hand. For example, some calculators, if you do 2 divided by 3, will give you the answer 0.666666, but other calculators will give you a number like 0.666667. The reason why you can get 2 different answers is because different calculators deal with rounding and approximating answers differently. Now this is very much related to an idea in science which is known as significant figures. Significant figures basically reflects the idea that our instruments that we use to take measurements are not always 100% accurate. For example, if you use a stopwatch, you may measure the time to be 3.47 seconds. Well, in reality, it's probably not exactly 3.47 seconds. It could have been 3.471 seconds or 3.472 seconds, and it's just that the timer that you have isn't able to measure down to that level of accuracy. Different classes have different rules for how you deal with significant figures. So for this class, we'll introduce some rules, but recognize that in your science classes, it may be slightly different. When we do addition and subtraction, we will always keep all the decimals of the calculation. If we do multiplication and division, we will keep 3 useful decimals after the decimal point. What this means is that if we have a number 0.000000125, we will keep the entire 125 and all the zeros before it. Later on, when we talk about scientific notation, you'll see why this is a useful distinction to have. Example, compute 1.2787 plus 3.6876 on a calculator. If you plug this into a calculator, you will get the following answer, 4.9663. Because this is an addition problem, we will keep all the digits from the calculation. Example, compute 1.57 divided by 1.06 on a calculator. If you do this calculation on a calculator, depending on the level of accuracy of your calculator, you will get something like this, 1.515444, 0.15444, and then maybe some more decimals after this. We usually notate the extra decimals, the fact that this continues on by a ... And in this case, it follows a specific pattern, but in general, this just means that there are more decimals to the right of this. Our rules for significant figures means that we're going to keep 3 useful digits after the decimal place. So 3 useful digits, and we will round. So this is approximately equal to 1.515.